All right, we're going to talk about inverse relations and functions, lesson 7 from unit 1 of pre-calculus. So, what are inverse functions? One function being an inverse of another. So, inverse functions are functions in which the independent and dependent variables are interchanged. The independent and dependent variables independent and dependent variables are switched. Now, there are two different ways to kind of look at and think about, whatever we're talking about, inverse functions. And one of them is kind of graphically, and let's kind of take a look at what that means. So graphically, inverse functions, when we're taking a look at these, something like this, make this a little bigger. Something like this. This blue one and the blue function and the red one are inverses. Now you notice when we take a look at the equations here, this blue one is f of x equals x squared minus 2, or y equals x squared minus 2. And then the red one is y squared minus 2. I don't know where the 2 came from. I guess, I don't know. That 2 maybe. 4. But then the other one, we flipped them. We took the x and the y and we switched them. Now, you might notice, and the reason why this green y equals x line is because I should have done this different than what was in the book. It's actually harder to tell. I should have just had this zoom standard because it's harder to see on this particular picture. But what is going on here? Let's see if I can actually bring. Why don't I bring this back up? Let's see. Well, no, it'll take a. Well, let me pause this recording and I'll bring it back up with a better zoom, maybe. All right, with a better zoom, because of the kind of letterbox window, it's easier to see there. Okay, so it's easier to see what's happening because when you graph an inverse relation in a function and then its inverse, then you can see that it graphically, it's like you took and you folded it and you reflected it across the line y equals x. And those two ways of talking about it are both accurate. So it's where you take the independent and the dependent variables and you switch them. And then also graphically, it's the reflection across the line y equals x. Let's kind of look at a couple other puzzle pieces. Now, not every function has an inverse. Okay, so not everyone does. In order for a function to have an inverse, it has to pass the horizontal line test. One in this class or some other class, probably this class. The other day was like, why isn't there a horizontal line test? Well, surprise, there is a horizontal line test. So what you're testing is you're doing it just like if, let's see, is that, yeah. You're doing a horizontal line test just like a vertical line test, where if we draw horizontal lines across here, if it touches the graph in more than one place, then it doesn't have an inverse. And by does it exist, what we really mean is, does it exist as a function? All right, so with this, like this particular one, I'm going to kind of probably do a relatively poor job. If we were to graph the line y equals x along here, if we were to take and flip this graph sideways, it would end up being a horizontal V. I've kind of clearly basically given up on trying to make it look good, but it would look something like this, where with this fails the vertical line test, and so therefore it is not a function. So it has an inverse, and that's I should make sure and clarify that. If it fails the horizontal line test, it has an inverse. It's just not a function anymore, right? So like our first example, let me see if I can pull that back. Yeah, our very first example, it has an inverse. The inverse of this blue one is this red guy. But that red one, even though it's his inverse, it's not an actual function, right? Because it fails the vertical line test. Okay, so that's what we're talking about here. So this one has an inverse, but not a function inverse, right? Now, what about, I think I've still got, my orange lines. Let me actually put them there. What about this one? See, this one would have a function inverse. This one, as we're graphing along here, a horizontal line never touches the graph more than once. So therefore, it would have a function inverse as well. Okay, so let's take a look at finding the inverse of a function. We're going to do a handful of examples. Let's see. I'll pull that up here in just a second. All right, so we're going to find the inverse of this f of x equals x minus 1 over x plus 2. So first of all, we're going to graph it on our graphing calculator. That's kind of what I had up just a half a second ago, was the graph of this to see whether it passes the horizontal line test, to see whether it even has a function inverse or not. So it does pass a horizontal line test. This guy does, because if we take and we do horizontal lines across the whole thing, it never touches more than once, even in here, because right here there's an asymptote, and so it's not gonna these lines don't get lower and lower, they level off because there's a horizontal asymptote right here on this graph. Okay, so this does have a function inverse. So since it has a function inverse, we're going to figure out what the inverse is. So the instructions would be determine if it has an inverse function, and then if it does, find it. Okay, so the steps to find it are pretty straightforward. So at the beginning, we said we're going to switch the independent and the dependent variables. In other words, we're going to switch the x and the y. So step one is to simply rewrite this equation with a y instead of an f of x. And this is mostly, you don't technically have to do this step. It is a good idea though, because it will help us with clarity, and we won't end up with extra random parentheses in there and all those kind of things. Now we're going to take and switch the x and the y. So we're going to take and put an x where the y is, and y's where the x are. Now, in order to put this in any kind of standard notation, we need to oops. I messed that up, didn't I? Y plus 2. Okay, so in order to put this in any kind of standard notation, we now have to solve for y. So in order to solve for y, the first thing we would need to do is get all this mess out of the denominator. So we'll multiply both sides by y plus 2, and then times y plus 2. On this side, we'll distribute. On this side, we can distribute as well. Timeout. It's been a long day. I'm tired, y'all. I was about to make some weird mistake and say we have to distribute on this side too, but no, this side cancels. That's the whole point of doing what we're doing. We are where we are. This is the, I don't even know how many videos I've made today. I've made a whole bunch. So let's keep on walking down. So when we distribute this x, we end up with y x plus 2x equals y minus 1. So now what we need to do, we're trying to solve for y, right? So we want everything that has a y on one side and everything that doesn't have a y on the other side, right? So we would subtract this y, do it over here as well, minus y minus y. I'm gonna scooch that over. We can't combine these two, not really, because of this x. We'll deal with that in a minute. But I'm going to scooch it over here because I'm also going to subtract 2x from both sides and go ahead and move that over. Okay, so these cancel and those cancel, and we're going to move this up right here. So we end up with yx minus y equals, excuse me, -1 minus 2x. You could write that in either order. We may decide later we want to switch it struggling. I'm glad that this is the last video I'm trying to make today because I'm making mistakes. If I make a mistake and it stays there, then you should probably, definitely, almost certainly let me know in the comments or on our class Discord server or even in class. It's okay. I can handle it. So over here, we've got all the y terms, and over here, we've got the things that don't have a y, right? So what we can do now is we can factor a y out because both of these terms have a y. So we're going to factor a y out, and then we're going to write down what's left. So when we factor a y out of this, what's left is an x. And then when we divide y divided by y, we have a 1, right? That equals -1 minus 2x. Now, the last thing we need to do to get y by itself is we got to get rid of all this. How is all of that attached to the y? It is, of course, multiplied. So how do we get rid of it? By dividing it. So we do the inverse to get rid of it. X minus 1. That cancels, leaving us with just y equals -1 minus 2x over x minus 1. We could write this one either way. Same with the bottom. It'd be the same difference. There we go. Did I get the same thing as the book? I better check because we already established that my brain is foggy right now. Yes, we did. All right, we're going to do one more example, and then we are going to be through with this lesson and I think actually this unit. Oh my goodness. Moving on up. Sounds good. Let's kill those off and look at, we're going to find the inverse. Well, first of all, we're going to find out if it has a function inverse. F, I'll do the example in white. F of x equals the square root of x minus 4. So in your graphing calculator, you can graph that. I already have it. It looks like this. So this guy passes the horizontal line. Oh, that's not going to be visible. Passes the horizontal line test quite well. Never touches more than once. So it does, in fact, have a function inverse. And so we're going to find out what the inverse is. Oh, I said this is the last example. There's actually one more thing after this. That's okay. We're at 13 minutes, 13 and a half minutes. I think we'll still stay 20 minutes-ish for the final product. So since this is now, we know that it has a function inverse, we're going to find it. So again, we're going to put a y right here instead of an f of x because it's easier to work with, right? And then bring everything else down. Then we're going to switch them. I really should probably notate that in my notes. I think that would probably make a good amount of sense, right? So we're going to take and put x where the y is, and we're going to put y where the x is. Now we've got to solve for y. This is a little teensy weensy bit tricky. Not really, not at all. How do we get rid of that square root? What's the opposite of square rooting? Squaring something. So that's what we're going to do first, is we're going to square both sides. X squared is x squared. All right. We got this. Equals y minus 4. How to get rid of that minus 4? That's easy peasy lemon squeezy because we just add 4 to both sides. So the inverse of... Oh, I don't think I notated that. I'm telling you. I'm telling you, folks. That didn't... Yeah. The notation for inverse is a little bit weird. So the inverse of f of x. Let's write this all out in words. The inverse of f of x is this symbol. Okay. So in this case, the answer would be the inverse of f of x is x squared plus 4. All right. Now, we have one more thing to squeeze in here. I think we can do it easy peasy, and we'll still be in a good way as far as video length, which is great. I like it when we're in a good way as far as that's concerned. So here is the one last thing. If we have two different functions listed, it can be helpful if we figure out, are they inverses? Later on, we're going to do the same thing, but for matrices and some other things along those lines. Let me get some water. My throat is scratchy all of a sudden. So there is a simple algebraic test for whether two functions are inverses. And we're going to write it out kind of formally like this. F of x and g of x are inverses if and only if f of g of x, we saw that in the last lesson, equals x, and g of f of x equals x. So if we do the composition of these two functions in both directions and it simplifies on down to x, then we know that this function is the inverse of that function. Let's do an example, and then yes, I'll double check, make sure I don't lie to you about the same thing twice. I don't mind lying to you about it once. That's fine. It's fine. It's no big deal. It's okay. So let's do an example of whether or not two functions are inverses. So, is f of x equals 6 over x minus 4 the inverse of g of x equals 6 over x minus plus 4. Okay, so is this one the inverse of that? So we're just going to do both compositions. And well, we're going to do at least one, right? Because if one of them turns out to be not come out to be x, then you can just quit right there. So let's start by finding f of g of x. So we're going to write down f with parentheses where that is, big enough to shove all that in there. So 6 over 6x plus 4, and then minus 4. So let's puzzle piece this our way through. Now there's nothing multiplying on this parentheses, so it can just go away and we can combine like terms here. 4 minus 4 is 0. So we end up with 6 over 6 over x. How do we get this out of the denominator? How do we divide fractions? This is going to be, if this is something that's not in your head, for whatever reason at this point, probably because you're in pre-cal and you've been using this guy for everything, and so you've been pretending fractions aren't a thing. But some of these fraction rules you really need to still be in your head because you'll need them. And we get to polynomials and you'll need them again, but with even more letters, et cetera, et cetera. But how do you divide fractions? Well, you multiply by the reciprocal. So this would equal 6 times x over 6, which of course, obviously, those cancel, leaving us with x. So this one passes the test. So we need to do it the other way around, and we still get x. Okay? So g of f of x, we're going to write g with parentheses where the x is, so we can shove all that in there. So 6 over a big old mess plus 4. So we're going to shove 6 over x minus 4 in there. So this guy is kind of an intriguing piece. It actually looks a little bit crazy too. We're going to use the same method to simplify this because we're dividing this by a fraction. So we're going to flip it over and multiply, right? So this equals 6 times x minus 4 over 6. It's going to cancel. Don't forget to bring over the plus 4. So those guys cancel, leaving us with x minus 4 plus 4. X minus 4 plus 4. The 4's cancel, leaving us with x. And so therefore, yes, it is the inverse. Now we're through. If you're one of my students, I shall see you in class. If you're not one of my students, thanks for being here. Whoever you are, don't forget to like, comment, and subscribe.